Hello everyone, Gareth the Master 974 here again today, and welcome to another Valve source code tutorial. This time around I'm going to demonstrate how you can create a sphere of sprites, which would be a nice sort of decorative entity. So as you'll see in the video footage that I'll provide, it is a sphere made up of little sprites, and the sprites are actual positions of a sphere based off of spherical polar coordinates, which I'll get into, but it's a simple way of creating a sphere of sprites without having to painstakingly, put sprites into particular positions based off of, say, cylindrical brushes and stuff like that, which can get really tedious, and I understand if you don't want to do that. So you can do something like this. So you'd want to create a test map to start off with, like what I've done here. And that's definitely not what I've done. Is I just screw up for no reason. But this is actually based off of the mathematical function visualizer map, and in some ways I am using some things that I would have mentioned in that video. But this is the entity that you want to create. It's called func_sphere, and you want to add a new parameter called radius and give it whatever value you want. In my case, I did 180. And if you don't know how to create an entity, then you can just create anything. So there's a soundscape, for example. And under the name here, you can just type in whatever you want. So I can type in ass and just hit escape. No, okay, something different. Big. There we go. Just type in big, hit apply, and then it creates an obsolete entity. And then you can go add what value, say 128, go OK, and that creates the new value. So that's how you do that. You could also go down the route of adding this into a .fgd file, but I'm not going to do that in this case, just because you don't really need to. So yeah, that's what you would do here, and I've added a soundscape entity here as well, just so you get an idea of what it's going to look like. It's just going to look something like this, just made up of little sprites where all of these different vertices are. So you could just get rid of that. And so the map's going to look like this, and I've already compiled it. So once you've done that, compiled the map and put it into your mod folder, let's navigate to the mod folder. So in my case, it's going to be here. So you can put the map in game mod episodical mod hl2 and then maps, and I've called it func tests, as you see it's right there. But we're going to go to our mod, src, and games solution. So we're going to boot this up. And I actually have the code that I'm going to use in this other window, so I'm just going to put that up. And so what we're going to do is go onto our server project, and somewhere on the server we're going to right click and add a new item, because we're starting from scratch. We're not using any pre-existing code to do this. This is purely fresh, like the mathematical function visualizer tutorial. And I'm also giving live commentary as well, so if you like this style, then let me know. If you want me to do the regular ass voiceover after the fact, then also let me know. But we're going to call this func_sphere, func_sphere.cpp, and it's going to add absolutely nothing because we're starting from scratch. So I'll bolster this up to 200% so you can see what we're doing. So the first thing we're going to do is do hashtag include. What we're going to include cbase.h, because this is going to be a point entity, and we want to be able to gain, all the information from point entities and in source. cbase.h is a good starting point for that. We're also going to do hashtag include sprite.h, because as I mentioned, we're going to be dealing with sprites. So we need to be able to gather the sprite information that we need. So if we don't do this, then we won't be able to do anything. And one of the things that is in pretty much any source file that you'll find is one of the last include files you need is tier0/memdbegon.h. Don't know why you need to do this, but it's better safe than sorry. And so we're going to define the class. So if I can speak properly, you can call this whatever you want to, but I'm going to call it cfunc_sphere. And what kind of entity is this? What sort of class is it? It's a C-base entity. So we create our new class called cfunc_sphere. It's going to derive from C-base entity, or it's going to be a C-base entity, and a point entity at that. So we can get into the public functions and public variables. Anything that's going to be accessible in other files is going to go here. So we're going to start off with a declare class, which is going to be called cfuncsphere, as it should also auto-populate. And then the base class name is cBaseEntity. So that's what we're going to do here. And we're also going to declare a data desk as well. So just do that like so. And we're going to have three major functions that we're going to use. We're going to have void precache, and that's going to pass through void, but we can just, get away with doing this. We're going to have void spawn, and spawn is also going to pass through no parameters, so we just do that. And we're also going to have another void function, and this is going to be called setUpPoints. And what we are going to pass through something here, and it's going to be a float called R. And that's going to be to actually set up the sprites. So that's what we're going to do at that point. And R is going to be our radius, which is related to the key value, as I mentioned here, because we're going to define radius as a key value or key field, and it's going to read the value of 180 and then set up a sphere with a radius of 180. And that's hammer units, by the way, as well. So that's why we're doing what we're doing here. And so that's why we're doing this now. So private is next, or you can do protected, but I'm doing private for a change. And so we're going to actually have a float called radius. And we're also going to get the vector position of the entity in the hammer map. And I'm just going to call it 0 point or origin or something like that. So that's what we're going to get. So precache is going to be for getting the material of the sprite. Spawn is going to get the origin of the entity and then run setUpPoints, which passes through our key field radius and then sets up the point around the origin of the entity, which is going to be the 0 point vector here. And so we're going to do link entity to class, and it's going to be what we call it in the hammer editor, in the source engine, funcsphere. And what class is it? It's cfuncsphere. So we do it like this. And then we're going to begin our data desk next for cfuncsphere. And I'm going to be Mr. Efficient and do end data desk at the very end here. And so in the middle, we're going to pass through our key field. So define key field. What is it called? Well, it's our radius float. What is it? Well, it's a float, so it's a field float. And what is it going to be referred to as? Radius. So that's how we go about doing that. So the radius float, which is used in the code, is going to be fed thanks to the radius name that's given in the parameter here. So it's called radius 180, and then we go in here, and then 180 is going to be assigned to the radius as a float. And we're also going to define a field, just a standard AS field, and it's going to be called 0 point. And what is this? Well, I'm going to say it's a field position vector, and I fucked up there, so I've got to type it out manually. But it can be a field vector, but say position vector. I don't think there's any real difference. So that's the setup for that. And so we're going to get into cfuncsphere precache. And what we're going to do in precache, well, we're going to do base class, and we're going to do precache. So one of the reasons we define cbase as well is so we can use base class. And base class is going to refer to cBaseEntity, and there's a whole bunch of functions in cBaseEntity, one of them being precache, another one being spawn. So base class calls upon cBaseEntity's precache, but then we can do whatever precaching we want to do in this file. So we're going to precache a model or material, whatever you want to do, but I think model is the one that's commonly used in these kind of cases. and it's whatever material you want to use for the sprite in this case. And so I'm going to use sprites/glow01.vmt, and because we're on the server, we do have to specify the .vmt extension here, as I would have mentioned in the mathematical function visualizer tutorial. And that's all we're going to do there. Then c func sphere : spawn to do the spawn function. And what we're going to do, well, we're going to do exactly the same thing for precache, just do base class and then spawn. And then we're going to define our 0 point position vector. And I'm going to say it's get absolute origin. So wherever the entity is placed in the map, that's the vector, the position vector, our 0 point, that we're going to be using. And then after that, as soon as we spawn and as soon as we get that vector defined, we're going to run our setup points function, but we need to pass through a float r, and our float r is our radius, the radius being defined by the hammer editor in this case, and defined in the entity when the map's compiled. So that is going to be 180 in our case. And so now we get into the meat of the video, which is going to be c func sphere : setup points, and this is going to pass through a float r. And so we're going to create two constant integer values. Now you might wonder, why are we creating them as constant values? Well, it's because this is going to be used for an array. And so we're going to have one called number of horizontal angles, and I'm going to say let's have 30 horizontal angles, and a second constant integer called number of vertical angles, and this is going to be slightly less, 15. And so from that we can create a constant float called horizontal angle. And to understand how we define a sphere, the way I'm going to define it is that we go 360 degrees in the horizontal plane and only 180 degrees in the vertical the vertical plane. So to get the angular extent that we're going to be iterating over, for the horizontal angle case we're doing 360 because that's a full circle, but divide that by the number of angles, and that gives us a value of 12. So it's going to go 0, 12, 24, 36, so on and so on until you get to 348. But we're not going to go to 360 because in the case of a circle, 360 is the same as 0, and we already have a 0 point defined. And we'll get into that a little later actually. So we can define another constant float, and this is going to be our vert angle. And we're only going to go to 180 in this case, and we go to 180 because if you imagine your hand, if you lay out your hand flat and that's a circle, then all you need to do is rotate your hand around 180 degrees, and your thumb is where your little finger is and your little finger is where your thumb is, and so that defines a sphere. You only need to go to a 180 degree turn to do a full sphere if you have a circle fully defined. And if you want to, you can switch the 360 and the 180 around, but generally this is how you would define a sphere. You define a circle by doing 360 degrees in the horizontal axis, and then rotate that circle around 180 degrees in a vertical axis, and then you get a full sphere. And so this is where things might get a little interesting and a little new, but we're actually going to define a matrix. So not an array, but a matrix of positions, a matrix of vectors that is going to define where the sprites spawn to visualize points on a sphere. And so the way we go about doing a matrix is not use one set of square brackets, but two. I know, novel concept, right? And for the reasons I've mentioned earlier, the fact that we only go 180 degrees in the vertical axis and 360 in the horizontal, but knowing that 360 is the same as 0 for the context of a circle, we're going to make the matrix the number of vertical angles plus 1 and the number of horizontal angles, as I show here. So the number of horizontal angles is what it is, because we don't want to go to 360 degrees because that's the same as 0, and 0 is already going to be defined. But for the number of vertical angles, we want to add 1 here because we want to get to 180, because that's a new point, a different point than 0. So effectively the vertical angles 0 and 15 in this case, because that's actually going to be 16 16 elements because it starts from 0. But 0 is going to be the top, 15 is going to be the bottom, and we want to define a point at the bottom, so we add 1 into the array element here at this point, but we don't do it for the horizontal angles because we already have a point defined at 0, and 360 is going to be the same as 0. So that's why we do what we do with this. And we're also going to create a Sprite matrix called asterisk p sprites. It's just the way you have to define it, and it's going to cover the exact same ground. It's number of vertical angles plus 1 and the number of horizontal angles, like so. And so we're going to create a nested for loop now, which is basically one for loop inside of another for loop, and we're going to go through all of the code that we're going to do here. So we can say for int I equals 0, then I less than or equal to the number of vertical angles, and then I plus plus, which is shorthand for I plus 1. And then immediately after this, we're going to do for int j equals 0, j less than the number of horizontal angles, and then j plus plus for j plus 1. So what we're saying is I is for the vertical angles, and we want to go less than or equal to, so basically from 0 all the way to 15, because this actually has 16 elements to it, with 15 being the last element. And then horizontal angles, we start from 0, but we want to go to less than the number of horizontal angles, and that's going to be 29, and 29 is going to be the highest number of the horizontal angles. And again, for the reasons I mentioned before about 360 and 180, and 360 equals 0, 180 does not equal 0. And so we do it in this fashion, a nested for loop. And so we're going to create a float called vertical angle. Actually, you're not going to do that just yet. That's a spoiler for something to come. Maybe you can figure out based off of what I'm going to say what this code might be like. But we're actually just going to go straight for the positions vectors. So the way we do this is to say positions ij. So it's going to go through vertical angles, and then for I equals 0, it's going to go from 0 to 29, and then do the same for I equals 1, and then I equals 2, and then I equals 3, and so on and so forth. And so for whatever element we're at, ij wise, and we're going to get the x Cartesian coordinate out. Now the thing is, as I mentioned earlier, we're going to use spherical polar coordinates because that's actually very handy for defining points on a sphere, much more than Cartesian coordinates, which is your x, y, z. So we know our radius because we've specified it, and we know our horizontal and angular extent at any point in this for loop, because it's just going to be 0 or 1 or 2 or 3 times our horizontal and vertical angle, which are actually both 12 degrees. So we can get the x, y, and z because we know what the horizontal angle phi and the vertical angle theta is. And we know that it's going to be based around our 0 point. So positions ij.x is our 0 point.x, whatever that is. And we're going to add on to that the spherical polar coordinate conversion, so because we know what r, theta, and phi is. And so it's for the x, it's going to be r multiplied by the sine of, and we have to use deg to rad because sine and cosine functions work in radians, not in degrees. So we have to, convert degrees into radians. I mentioned this in the mathematical function visualizer tutorial, so you can go and watch that for more information about that. But it's basically sine of the vertical angle multiplied by the cosine of the horizontal angle. So this is what we would do. It is r, which is our radius that we pass through from up here. Then it's sine, as I said, of radians of I times the vertical angle. And then we multiply that by the cosine of deg to rad of j times the horizontal angle. And so that is how you get the x component of spherical polar coordinates when you know what r, theta, and phi is, right? Or yeah, so it should be r, theta, phi if you look at my mouse there. And so we can do that for positions I, j, dot y. And then you have to understand what the conversion is in this case. And so it is r times the sine of deg to rad of I times the vertical angle. And then we multiply this by sine of deg to rad of j times the vertical angle. Sorry, the j times the horizontal angle, excuse me, I'm fucking up. And then lastly but not leastly, positions ij dot z is 0.z plus r times the cosine of deg to rad of I asterisk the vertical angle. So basically, x is r sine theta cos phi, y is r sine theta sine phi, and z is r cos theta, where theta is the vertical angle and phi is the horizontal angle. I could show you on screen right now what the inverse relation is to that. So if you know what x, y, and z is, but you don't know r, theta, and phi, it's way worse, trust me. It's horrible to look at. So be thankful that this is what it is. It's actually fairly straightforward. But what we're saying is positions ij is a matrix, and it's a matrix of vector positions. The vectors have x, y, and z components to them. We define what the x, y, and z is based off of a conversion from spherical polar coordinates, which is given by what we defined right here. It looks nasty. If you've not come across it before, then it can be quite daunting, but just take comfort knowing that what I've put here is correct. And so for the Sprites aspect of it, we say that P Sprites ij, so it's again the same sort of situation. It's a matrix of different sprites, and we're going to spawn the sprites at different positions by doing C sprite : sprite create, and is going to ask for a material which we defined in precache as sprites glow01.vmt. Where do we want it to spawn at? Well, we want it to spawn at positions I, j, because we've just defined positions ij and specified the x, y, and z coordinates independently. So whatever the x, y, and z total vector is where this is going to spawn. Do we want it to animate? No, we don't. So place. That's exactly what yeah, you know what I mean by place. It means false. And so because of this, if Visual Studio wants to play ball with me and I'm not like fucking retarded or something, we do psprites ij arrow to then define properties of the sprites that get spawned. So because they might be very large, we want to decrease the scale of them to make them pretty small. And we can also do this kind of horrid line where we just set the transparency. So set transparency. So we want it to be a glow. So not one where there's black borders around it, it looks like squares. Make it an additive or a glow. We're going to make it pure white and pure bright, so just pass through 255 for everything. And we're also going to have k-render effects no dissipation as well, just because. And we can add a little debug message at the end as well, so we can see how this works in action. So we can say, for example, positions %i, which matches positions ij up here, are at, and say %.4f, 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 \n. And so if you watched episode 1, episode a half, there's a video on that. But it's basically debugging messages to the console. %i passes through an int. What integer values do we have? I and j. So those would be the first 2 %i's, positions I, j. And where are they at? Well, they're going to be at positions ij.x, y, and z. So you can just pass that through as so. Get the fuck out of here. Again, what the hell? I'm not trying to paste and it's not doing it. There we go. Something like that. So it's positions I, j are at x, y, z is basically what that line is saying. And so if you save this and compile, then it should build with no errors as long as you do exactly as I say. And especially don't modify this bit with the spherical polar coordinates, because that's integral to the whole thing. So as long as it's 0.xyz and add on the correct conversion for each bit, then you should see something that looks like what I'm going to show you right now, which is going to be a sphere. So supposing you've done what I said in the Hammer editor and compiled the map ahead of time, then you should see a sphere that looks kind of like this. And so yeah, this is a sphere. Each point is a point on a sphere according to spherical polar coordinates. Now, as you might be able to tell, you can see the top and the bottoms looking a little different. And so this is where we load up the developer console, and we can see, for example, all of these points down here are basically at the same point, right? So if I blow up the video and I can show this section right here, then it will say positions 15, 0, 1, 2, 3, 4, blah, 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 are all at the same place. And so there is a way that we can go through this and basically get rid of some of these repeating points, because, you know, optimization purposes and all of that, right? So there is a way we can do this, and any of the eagle-eyed viewers amongst you might have realized that this section right here for vertical angle is 0, then the sine bits up here are going to go to 0, and so the only real bit that matters is this cosine bit, but we iterate over 30 horizontal angles, and so we just get, well, more like 29, but it's 30 at the same point, right? But we only want one. So how do we do that? And so this is what I was actually going to start off with, is we create a float called vertical angle to use. And what I'm going to say is that this is equal to I multiplied by the vertical angle. And so you can replace I times vertical angle with VANG to use if you want to. I'm not going to in this case. And I'm going to use something called the modulo operator, which is basically the percent symbol. But for that to work, you need to actually pass through an integer value. So I'm going to create an integer called f, and this is going to be the integer value of our VANG to use float. And so the reason I do this is in case the vertical angle here is something other than 12. You know, if you go to a certain number of number of points or whatever, a certain extent, this might not be 12, it could be 6.5, for example, or 3.5, or 1.5 even. That would be a better one to say. And so, yeah, it's not going to work because you're passing through a float. To use the modulo operator, which needs to pass through an int, but it's only really applicable to the start and the end points. So what can we write code-wise that would exit these for loops when we're at the start point and the end point of our vertical angles, and make it so we only get one point that's defined and one sprite that spawns at that specific location? And so the way I would go about doing this is to say if, and we do two sets of brackets, and we're going to have condition 1, which is if our angle to use is exactly equal to 0, i.e., I equals 0, therefore this goes to 0 and it's our starting point. Or, and this is where I mentioned the modulo operator, if f%180 equals 0. And so what this is saying is if our vertical angle to use is 0, or if f which is the integer value of our angle here, divided by 180, leaves a remainder of 0. So that it could be 180, 360, 540, so on and so forth. As long as it's a multiple of 180, then we're going to enter this condition. But there's other conditions as well. So for example, we're going to say, and if I is greater than or equal to 0, so that's our vertical angle, so that covers element 0, and also j is greater than 0. And so j greater than 0 means it has to be 1, 2, 3, 4, 5, 6 or higher, but it can be 0. And that way you get 1 point that gets defined. It's going to be at 0, 0, and then say for example 15, 0, or more like 14, 0, whatever the case is. So if we're at 0, our vertical angle is 0 or 180, or at least the vertical angle divided by 180 gives a remainder of 0 if our I index is greater than or equal to 0, and if the j index is greater than 0. What do we want to do? Well, we want to break out of the loop, so we're going to use the break keyword to exit out of the for loop early. And so you can use that, build the solution, and what you should find is that if you look at the developer console that tells you exactly where these positions are, you should only get 1 point at the top at element 0, 0, then it goes element 1, 0, 1, 1, 1, 2, and so on and so forth, as I should show in the video right around here. As you can probably see here, 0, 0, then it goes 1, 0, 1, 1, blah, 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 blah. It goes all the way through until the very end, where you only get 1 at the bottom. And if you see, the sphere looks kind of normal, doesn't it? It looks like every point there's one sprite. There's no sprites repeating or anything like that. So that's looking pretty cool, but there is something that you desire, isn't there? The ability to manipulate the points, so to speak, to make this move, because it's all static at the moment and we can't have a static sphere now, can we? Well, there is something we can do. And so the one thing that we can do is go through a think function, right? No. For whatever reason, I could not get a think function to work, and that would animate the points and all the sprites through code. But we actually don't have to do that. It's nowhere near as complicated as that. And we just make a change here. And so we say psprites ij arrow set parent this. And so what this line is saying is that the sprites that get spawned at these vector positions, which is basically based off of spherical polar coordinates, it's going to be parented to the func sphere entity. So in the hammer editor, if our func sphere is parented to something like a rotating entity, then all of the sprites are going to rotate based off of that rotating entity. And so in my case, if I turn no draw on, then you can see I've already created a func rotating. It's got a rotation speed of 20, it's set to start on, and because it's called rotator, what we can do is select our fonts here, and then go add parent name, because that is how you refer to the parent, call it rotator, go OK. So basically it's going to be parented to whatever's called rotator, which is our rotating entity. And so if I go back to the code here, because I've already done this for my map, all I need to do is build the solution, load into the map, and then you should see the sprites rotate around, and that's how you can manipulate the sprite positions. You don't need to do it through the code, you can just do it through the hammer editor, like so. So yeah, look at that, we've got her sphere, and all the points are appropriate to that of a sphere with a radius of 180 hammer units, and it's just rotating around very slowly. So that is the tutorial, ladies and gentlemen. I hope you found the tutorial helpful, and hopefully you follow along, and hopefully it's not too complex for you. But if you follow along with what I say, then this is how you can have a nice decorative sphere entity in your map. So with all that being said and done, leave a like, comment, subscribe and all that. You can check out my Gareth the Gamer channel as well if you want to. I did a pretty lengthy video on Future Arm of the game. And I'll be back at some point in the future with more Valve source code tutorials, I think, and other kinds of videos. If there's anything you want me to cover, then let me know. But more importantly, take care out there, have a fantastic day, and I'll see you for whatever I decide to do next. Thank you.